Energy, matter, and change. Physical science is all about how matter and energy change. Any matter that has energy can change itself or other matter. Matter can get hotter, colder, faster, higher, or change in many other ways. The world around us has a constant flow of energy between and through matter, creating changes as it goes. Energy can exist in many forms, such as heat, motion, height, pressure, and electricity. Energy is also contained within matter itself, like the energy in food. The energy stored in food is an example of chemical energy. The diagram below shows some forms that energy can take. You have probably heard of many of them. Energy can change from one form to another. Maybe you are reading this book under an electric light. It takes energy to make light. Where does this energy come from? Before it became light, the energy was carried by electricity. Electricity is a modern way to transport energy from one place to another. The energy was changed into the form of electricity by your local power plant, but the energy itself was not made in the power plant. The power plant changed the chemical energy found in gas to heat energy by burning the gas. The heat energy was used to turn water into steam, and the steam powered into a machine called a turbine. The mechanical energy of the spinning turbine provided the power to run the electric generator, which produced the electric energy. More about energy. You can think of energy as nature's money. Anytime anything changes, energy must be exchanged. 1. You use energy to throw a ball, change in speed. 2. The stove adds energy to a cup of tea, change in temperature. 3. Water loses energy as it flows downhill, change in height. Each change costs a certain amount of energy. An object can only change as much as the energy allows. Bigger changes cost more energy. Smaller changes cost less energy. The amount of change you can have is limited by the amount of energy available. Both living creatures and products of technology get virtually all of their energy from the sun. Without the sun's energy, Earth would be a cold, icy place with a temperature of negative 273 degrees Celsius. As well as warming the planet, the Earth's energy drives the entire food chain, figure 119. Plants use the energy in sunlight to make sugars from carbon dioxide in the air and water from the ground. Plants store the sugar as energy. Animals eat the plants to get energy. Other animals eat those animals for their energy. It all starts with the sun. A lot of the energy humans use come from gas and oil. This energy also comes from the sun. Over millions of years, the Earth's surface has moved around. Some areas that were once vast jungles got pushed underground long ago. Gas and oil comes from the decay of plant matter buried underground for millions of years. This plant matter was originally created from energy from sunlight, so gas and oil are really a form of stored solar energy that was laid down over millions of years. We need to be concerned about using up gas and oil because once it is gone, there will be no more for millions of years to come. What do you do when you want to move a box across the floor? You push it or pull it. Pushing and pulling are examples of force. Most of the changes that occur in the physical world are caused by forces. Sliding a box across the floor is a change in the position of the box. That change can only be caused through the action of a force. A force is a push or a pull, or any action that is able to change motion. You need force to start things moving, and also to make any change to their motion once they are moving. Forces can be used to make an object go faster or slower or turn in a new direction. The thing to remember is that force is an action. Some forces act to cause things to change. Other forces act to keep them from changing. Forces are created in many different ways. Your muscles create force when you push a box. Earth's gravity creates forces that pull on everything around you. On a windy day, the movement of air can be creating forces. Each of these actions can create force, and they all can change an object's motion. What creates the force? Forces require a source of energy. You use energy from food to create forces with your muscles. Lifting a book against Earth's gravity takes energy. If the book falls down again, its energy can make forces on anything it hits on the way down. The motion of the wind is caused by the energy from the sun being absorbed in the Earth's atmosphere. Energy moves through the action of forces. In fact, one simple way to think about energy is as a stored ability to create forces. Understanding changes. Science is about understanding how and why things change. Lots of different kinds of changes happen around you every minute. You can understand some changes by thinking about what you can actually see and touch. Other changes are harder to explain. Here is an example. Imagine being in the woods on a cold evening, stirring a pot of cocoa over a fire. Think about these three changes that happen. 1. The cocoa is moving as you stir it. 2. The cocoa in the pot is getting warmer. 3. The wood in the fire is burning to make heat. The first change is the easiest to understand. Stirring makes a force on the cocoa in the pot, which makes it move. This kind of change can be explained with the ideas of force and motion discussed in Unit 2. Getting warmer is a change in temperature. Temperature changes are caused by forces in motion, only of a smaller size. To understand temperature, you need to know that matter is actually made of tiny particles called atoms. Atoms are so small there are more than 200,000 of them fit in the thickness of a sheet of aluminum foil. Figure 123. Temperature changes come from the forces and motion of the trillions of tiny atoms inside of matter. Change is the hardest to understand. How does one kind of matter change into completely different kinds of matter? For example, once the wood in a fire has burned into ashes, it does not change back into wood again. The matter that started as wood has changed into another kind of matter that's completely different. How? The answer to this question has to do with the atoms. The forces between atoms sometimes cause them to combine with each other to form completely different kinds of matter. Atoms so important. For thousands of years, no one knew that atoms existed. Why is it important to know about atoms now? If atoms can't be seen, how do we know they exist? It's important to know about atoms because atoms explain all the properties of matter. We cannot understand chemistry or physics without atoms. Modern technology has become powerful enough that we can see and use atoms. For example, atoms are split for energy in nuclear power. Scientists even move single atoms around and make structures out of atoms. Before people understood about atoms, the changing of ice to water was a mystery. Imagine an ice cube. Solid ice acts differently than liquid water, but ice can change into water and water into ice. How does this happen? The answer involves forces between atoms. Atoms attract each other when they are separated. In science, the word attract means a force. Each atom feels an attractive force pulling it toward every other atom. If the force is strong enough, the atoms all stick together in a solid, like the atoms in ice. Ice is a solid because the atoms are stuck together by attractive forces. The temperature of the matter goes up. Each atom starts to wiggle around. That's because heat is a kind of energy. When the atoms absorb heat energy, they move. The higher the temperature gets, the more the atoms wiggle. Temperature keeps rising. Eventually, the wiggling motion overcomes the attractive force sticking the atoms together. When that happens, atoms are free to move around and switch places with each other, and the ice melts to a liquid. Liquid water flows because its atoms are not stuck tightly to each other as they are in ice. Look around you. You can probably see over 100 different kinds of matter: cloth, concrete, wood, metal, chalk, glass, leather, grass, etc. The list seems endless. Many kinds of matter, like the plastic, are made from other kinds of matter, such as oil. It is possible that the millions of different kinds of matter are all made from something simpler. Could water be a combination of other things, just like a chocolate cake is a combination of ingredients like sugar, flour, and eggs? The answer is yes. Just as 1,000 words can be made with only 26 letters, all the millions of different kinds of matter are made from about 90 different kinds of atoms. Each kind of atom is like a letter in the alphabet of matter. The word water is spelled with 5 letters. The word water molecule is spelled with 3 atoms: hydrogen, oxygen, hydrogen, or HOH, usually written as H2O. Each molecule of water has one oxygen atom and 2 hydrogen atoms. Every different kind of matter has its own unique combination of the 90 basic kinds of atoms. We call each kind of atom an element. An element, like gold, is a pure form of matter that cannot be broken down into other elements. All atoms have the same element, are similar to each other, and different from atoms of other elements. If you examine 1,000,000 atoms of carbon, they would all be similar to each other, but different from sodium, aluminum, or oxygen atoms. Pause here and answer these questions.